Hello, everybody. My name is Florian Dukaushe, and this is my final presentation for the 260 class. Let me quickly open my PowerPoint and let's get started. Okay. Okay. So, as we know, in Java, there are two types of variables. We have the static class variable and non-static or instance variable. The memory for static variable is created only once in the program, that is at the time of loading of the class. In static variables, they are preceded by static keywords. So in order for one to identify a static variable, you have to look out for the keyword static in front of that variable. For non-static variables, it is created at a time when the object of a class is created. These variables are not preceded by any keyword. Okay, it's just the data type and the variable. Now let's take a look at some differences between the non-static and static variables. As discussed earlier, for the non-static variable, there shouldn't be any keyword preceding the variable. So for example, for class A, we have this to be the non-static variable. Here's the data type, the variable, and a semicolon. For the static variable, whilst for the static variable, it is preceded by the static keyword. So for example, for this class, we have static, the data type, the variable, and semicolon. Another difference is that the memory for non-static variable is allocated for them whenever an object is created, whilst for static, the memory is allocated when a variable at the time of loading the class. So the memory is created at the time of loading the class. Also, memory is allocated multiple times whenever a new object is created for the static variable, whilst for the non-static, whilst for the static, memory is allocated. For non-static variable, it's also known as an instance variable. And this is because memory is allocated whenever an instance is created. And for the of the class. Okay. Now, another difference is that non-static variables are specific to an object, whilst static variables are common for every object. That means the memory allocations can be shareable by every object reference or same class. Okay, so now let's go to NetBeans and take a look at some examples of static and non-static variables. So let's go down. Let's open the move view. Oh, it's taking a bit longer. Okay. So in the move view, as we can see, we have this non-static method here. Okay. And down here, we have all these being non-static variables. Okay, as we can see, there is no keyword such as static in front of it. Let's take a look at an example of a static variable. So let's quickly open one of the classes. So as we can see here, the player variable is preceded by the keyword static. And this clearly shows us this static variable. Also in line 31, the variable monster is preceded by the word static. And this shows that it's a static variable. Okay, now let's take a look at arrays. Now, arrays are used when the length of the list is fixed and one wants to dynamically change the items in the list. Now, all items in the list must be of the same data type. So if it is int, all the items in the list are int, the data type. Okay, let's take a look at some examples of arrays. So let's go to the map control. Let's go down. Okay, so here we have a group of two-dimensional arrays. Okay, and they are length. So in the game, at this location, these are the lengths. Okay, at this location, these are the lengths. So these are two-dimensional arrays that we have. Now let's take a look at array list. Now an array list is a class that comes straight with Java. Okay, array lists are a good choice to use when a programmer needs to dynamically add or remove elements to a list in a program. Array list objects does not have a fixed length. So unlike arrays and enums, which have fixed length, array lists does not have a fixed length. Okay, now let's take a look at, and before we go to enums, what differentiates an array list from array and enums is the use of the keyword new. So in initializing and declaring an array list, the keyword new is used. Okay, now let's take a look at enums. Now, an enum list is similar to an array in that it has a fixed length, as I said earlier, and all of the items in the list must be of the same data type. An enum differs from an array in that the items in the list are constant or final. That is, the values assigned to each item in the list can never change. The items in the enum list are not addressed by an index like an array. Rather, each item in the list is mapped to a keyword. An item is located using its associated keyword. Okay, so let's take a look at some enums. Now, taking the actor enum, as we said earlier, an item in an enum is located using its associated keyword. And in this instance, in order to define an enum, to serialize it, we put the word enum in front of it. Okay, and the list, as we said, an item is located using its associated keyword. So these are the list, and they all have the same data type. Okay, they all have the same data type and a fixed length. Now these are the keywords, and these are the values. Keywords, values, keywords, values. Okay. Now we ask ourselves a question now. How do we navigate through a list of items, okay, in Java? Now, the most basic format for navigating through a list of items in Java is the use of a basic for statement. Okay, so by using loops, such as a basic for statement. We are able to navigate through a list of items in Java. So let's take a look at a for statement and let's see how it works. Okay, so in my map control, I think I have a for statement somewhere. Okay, so this is a for statement. Now, in this statement, we are saying row, which is called a counter variable because of the increment of 1 indicated here. Will start from 0, and it would run according to this condition. That means the length will be less than the length of the location array. So from 0, it will go to 1. As we can see here, there's an increment of 1. Goes to 1. If the length of row is less than that of the location array, the same process will go on again. It gets to 2, and gets to 3, until the length of the row is equal to the location array. Now, in this instance, the row, which is the same as the counter variable, is also acting as the index in this situation. Okay, and this shows that the results that will be printed. The same thing applies for this for statement we have down here. Okay. Now let's talk about exceptions. Now, in order for us to avoid going or running through the code step by step to explicitly check for runtime errors after each function, we rather use the exception handling. Okay, and this eliminates the need to explicitly check for runtime errors after each function. Okay, after each function is called in the calling hierarchy. So in our program, we created some exceptions, and let's see how it actually works. So taking the escape view, okay, before we go to the escape view, before an exception would work, an exception file would have to be created. So in this instance, we have a couple of exception files here. We have the battle control exception, calculator control exception, game control exception, item control exception, and the map control exception. Okay, as we can see, we have the map control exception here. Okay. Now, in order for us to throw an exception in a view, we use the word throws followed by the name of the exception. So let's look at the escape view. Then, okay, there we are. So in the escape view, to throw the battle control exception, in this case, we write throws. Okay, and the exception name. Okay, now what we want to happen here is that the user should enter a number between 0 and 10. Okay, now if the user enters number between 0 and 10, the program will work accordingly as expected. But what will happen if the user enters a number below 0 or above 10? Now, let's take a look at the try catch statement. Now, here we are saying that the user should input the values as indicated above. Now, if it meets this condition, that if the input length is less than 1, there should be an error. Okay, so this error will be thrown if it is less than 1. So the value, it would print out to the user, value cannot be blank. Now this will continue. If this condition is not met, then the next condition should be met. So the else statement, then it tries to do the same thing for this condition. So if the value is less than 0 or value is greater than 10, an error would be printed out to the user again. Value has to be between 0 and 10. Else, now after the error has been caught, in order for us not to go through or check for runtime errors ourselves, the catch statement, the error is propagated to the catch statement. Okay, and this is indicated. Value must be a number. Okay, and the same thing happens for this catch statement. That error is thrown, and it would be shown to the user that there is an error. So you should re-enter the number according to the conditions that has been given. Okay, so the difference between a character string and a byte string is that character string class are used when using plain text, while byte string read from a file, 1 byte at a time. Now let's go back to my PowerPoint and let's take a look at some differences between character string and byte string. Now, as we know, Java defines 2 types of streams. They are byte streams and character streams. Now, for the byte streams, they are the most basic type of streams for input-output operations and are used to process data byte by byte. That's 1 byte at a time. Okay. Now, byte-based streams generally end up using the word stream, like input and output streams. Okay, and are used to process a raw byte at a time. But there are some exceptions of byte streams that do not use the keyword stream. We have the data input streams and the data output streams. Okay, now let's take a look at character streams. Now, for the character streams, they provide a convenient way for handling character inputs and outputs. Okay, this can be used for internationalization purposes as character streams use Unicode characters. So you could say that the character streams consist of many bytes. Okay, they comprise of many byte streams. Okay, now these are some examples. We have the input stream reader, file reader, output stream writer, and file writer. Okay, and let's go into NetBeans and take a look at how a document can be printed out. Okay, so let's take a look at the game menu. Let's go down. Okay, there we are. So here we want to print locations. Okay, so we tell the user to enter the file path. Okay, to enter the file path, and if the file path is correct, what has been entered will be captured. Okay, and this would be printed out to the user. Your file print completed successfully. Okay, but if the file path is not correct, an error will be thrown and that will be propagated to the exception. Okay, in the game view menu, and that this will be printed out as your file did not print completely successfully. Okay, so this is a way to print a report in Java. Okay, now let's run the game and see how our game works. Okay, now before we do that, let me close these ones so we have a clear view of how the game works. Okay, so Let's run it. Okay, let's wait for it to run. Okay. Okay, while it's loading, let me just wait for it to finish loading. Okay, there we are. There we are. It says that you enter my name. My keyboard is not actually working well, so you pardon me. I might use my on-screen keyboard. Okay, so let me enter a name. Flow. Enter. Okay, now it says our main menu. Let's start game. So M. Enter. Okay, now I can choose a character. C. Then I can choose probably a warrior. That's one. Now let's choose a map. So this is our map, as you can see here. Okay, so let's choose a view. Okay, so we also have a list of inventory, as you can see there. Now let's print location P. Okay, so you can see, say we should enter. Let me hide this. Enter the file path profile where the game is to be saved. Okay, now let's print name. So PP. Okay, so I can make a selection. I can still choose. Now let's test our math skill. So let's go to T. Say please choose your first number. So let's choose 2. Let's choose 6. Okay, now error value must be plus. Okay, so it throws an error. So let's go according to the error. So please choose a second. Value must be a number. Okay, just as we indicated, when there are errors, okay, it would show in the view. So now we have an equation. So 2 plus 4, that is 6. Okay, as we can see, the program is working correctly. So let's go to the previous menu. Okay, so we have back to previous menu. Let's go to help. Okay, so let's go to the goal of the game. Okay, so now we can move. Let's try move. Okay, so we can go to back to story. Okay, so as you can see, whatever we do, we have it up here. So these are the storyline. Okay, so the game is functioning well. There are no problems. Hopefully, I will be able to apply these wonderful skills in the future, especially in Java 2, that's the 360. I thank the instructor for being patient and for letting me be part of this wonderful class, and also my team members, Brother Murray and Brother Greg. Thanks for watching, and see you next semester.